Hi, welcome to the video to go over homework 1, statistics review. The first 6 questions were related to this abstract about a study looking at the efficacy of duct tape versus cryotherapy, which is freezing, in the treatment of common warts. The objective of the study was to determine if the application of duct tape is as effective as cryotherapy in the treatment of the common wart. The design used a prospective randomized control trial with 2 treatment arms for warts in children. They took a total of 61 patients who were enrolled in the study. 51 of them completed the study and were available for analysis. Patients were randomized using computer-generated codes to receive either cryotherapy, which is the liquid nitrogen freezing, for a maximum of up to 6 treatments, or duct tape applied to the wart for a maximum of 2 months. Patients had their warts measured at baseline and at return visits, but the main outcome measure was complete resolution of the wart being studied. The results tell us that of the 51 patients completing the study, 26 were treated with duct tape and 25 were treated with cryotherapy. 22 patients in the duct tape arm, which was 85% of them, versus 15 patients in the cryotherapy arm, which was 60% of that group, had complete resolution of their warts. There's a p-value of 0.049, which was calculated by using chi-square analysis. So first of all, we're asked what the explanatory variable is, or the independent variable. And remember, the explanatory variable is the piece of information that we're collecting from each subject that we're using to, we think, may be influencing the response. So here, the thing that we think might be influencing is the treatment. So the treatment, whether they're receiving duct tape or cryotherapy, is our explanatory variable. And the primary response variable, you can see the main outcome measure, was complete resolution of the wart being studied. So whether the wart completely resolved or not is really our primary response variable. The results section reports that a chi-square analysis resulted in a p-value of 0.049. You can see that that's a typo. And we want to know what were the null and alternative hypotheses for the test. When we do a chi-square test, a chi-square test always has the null hypothesis that there's no association between the variables. So in this case, it would be no association between the treatment and wart resolution. This would mean that duct tape and cryotherapy are equally effective. The alternative hypothesis is that there is some difference, some sort of association between the treatment and the response. And so this would mean that there's some sort of difference in the effectiveness of duct tape and cryotherapy. One thing to realize is that a chi-square test is always a two-tailed test. It will look to detect a difference in either direction from the null hypothesis. So chi-square test will give us the ability to detect a difference if duct tape is more effective than cryotherapy, but it would also give us the ability to detect a difference if duct tape were less effective than cryotherapy. fourth question really was just getting us to think critically about what the p-value is measuring. There are a lot of misunderstandings regarding what the p-value actually measures. A p-value is a conditional probability. It's the probability that we would observe our data, or something more extreme, if the null hypothesis is true. One of the common misinterpretations is to reverse the conditioning and to think that it's the chance that the null hypothesis is true given the observed data, but that's incorrect. And that's really what this first statement is. The probability that there's no difference, that would be that the null hypothesis is true, that is not the correct interpretation. So this is invalid because it's not talking about the chance of seeing our data, or something more extreme, if the null hypothesis is true. There's no reference to the sample data at all in this interpretation. The next one, it states that the probability of the difference in the chance that a wart will be resolved depending on whether it is treated with duct tape or cryotherapy is 0.049. Again, this is not a correct interpretation. This doesn't make any sort of reference to our sample data whatsoever, and it also does not make any reference to the null hypothesis. So it's not a correct interpretation of the p-value. This third one is the correct meaning of a p-value. If, in fact, there's no difference in the chance that a wart will be resolved, depending on whether it's treated with duct tape or cryotherapy, this is saying, if the null hypothesis is true, the chance of obtaining a difference as large as the one observed in the sample data is 0.049. This is the chance of seeing our sample data, or more extreme. If the null is true, that's the correct interpretation of the p-value. And it's because of this interpretation, a small p-value tells you that your data are not consistent with the null hypothesis. They're something that shouldn't occur very often if the null hypothesis is true, and would give us strong evidence to reject it if that p-value is small. So based on the p-value, which was approximately 0.49, we're going to think about what conclusion we reach regarding the efficacy of duct tape compared to cryotherapy. Remember that usually the cutoff for statistical significance, which we call alpha, is 0.05. And p-values that are smaller than this are the ones that give us strong enough evidence to reject the null hypothesis. In this case, our p-value is just a tiny bit less than 0.05, which means that we've got strong evidence to reject the null hypothesis in favor of the alternative. Now remember, our alternative hypothesis is that there's some sort of difference in effectiveness between duct tape and cryotherapy. But we can actually tell by looking at the direction of the difference which of the therapies is more effective. So because we know that 85% had their warts resolved in the duct tape arm and 60% resolved in the cryotherapy arm, then if there's a difference, it must be because duct tape is more effective, not because cryotherapy is more effective. So, the sample gives strong evidence that duct tape was more effective for treating warts among the study group. Essentially, what this is telling us is that the difference that we saw is statistically significant, and it's unlikely to be due to chance. It should be due to the fact that duct tape was, in fact, a more effective therapy. Question 6 asks, if we were to make a confidence interval for the difference in proportion of warts resolved in 6 weeks for each of the 2 treatments, would we expect that interval to include 0? So keep in mind the difference in proportions, a difference of 0 would mean that the 2 proportion that were resolved would be the same in both groups. And so really what that would mean is that the 2 treatments were equally effective. But we know based on the chi-square test that the treatments aren't equally effective, or at least that there's strong evidence that they're not equally effective. Since the sample gave strong evidence that duct tape was more effective than cryotherapy, a difference of 0 shouldn't be a plausible difference, and so it shouldn't be contained in the confidence interval. So we can kind of think of using a confidence interval as a sort of informal way of testing hypotheses. If our hypothesized value for the difference is in the confidence interval, then we should think, well, that would mean that it's plausible that the null hypothesis is true. If the hypothesized value for the difference that we see in the null hypothesis is not in the confidence interval, then we'd say, okay, well, it's not plausible that the null hypothesis is true. In this situation, the null hypothesis would be that the difference would be 0. And so since we rejected that null hypothesis, we shouldn't consider 0 to be a plausible value for the difference, and it won't be in that confidence interval. Questions 7 to 10 focus on this article, looking at indoor coal use and early childhood growth. This particular study was done to examine whether indoor coal combustion for heating affects early childhood growth. They used a prospective longitudinal study with growth measurements extracted from medical records of the children's well child care visits at age 36 months. There were 1,033 children followed from birth to age 36 months. The main exposure was maternally reported use of coal for heating. So that's going to be our explanatory variable. Whether coal is used for heating in the household. The main outcome exposure was the Z-score for height for age and sex at 36 months. So the Z-score for height at 36 months is our primary response variable. Remember that what a Z-score is, it tells us how many standard deviations away from average a particular child's height is. If it's positive, it means the child is above average height. If it's negative, it means the child is below average height. Just to kind of refresh our memory of what a Z-score is. Question 9 says that the results section reports a 95% confidence interval for the reduction in height for boys raised in homes that use coal for heating of 0.51 to 2.16 centimeters. We want to interpret this confidence interval in context. So remember that in general, a confidence interval is an interval that we're 95% confident includes the true value of the population parameter that we're trying to estimate in that interval. So we need to think about what the population of interest is here before we can interpret the confidence interval. And we also need to think about what the parameter is that we're trying to estimate for that population. So as we look at it, we can see that they were looking at people in two particular districts in the Czech Republic. So maybe our population is all children. Born in these districts of the Czech Republic. And since we're looking at height, the parameter we can think about is sort of the mean or the average reduction in height. So here we're looking specifically for boys. So I'm 95% confident that the mean reduction in height among all boys age 36 months living in these districts in homes heated using coal is somewhere between 0.51 and 2.16 centimeters. And you may have worded the population slightly differently and the parameters slightly differently, but the key thing is that we need to think about what population this estimate applies to, and we need to recognize that it's the mean reduction in height in that population that we're 95% confidence is in the confidence interval. The last thing I wanted to talk about in question 10 asks, based on the confidence intervals, do you think the study data provided strong evidence that the reduction in height in homes that use coal for heating differs between boys and girls? So when we look at the sort of confidence interval for the reduction in height, for boys, we know it went from 0.51 centimeters up to 2.16 centimeter reduction. And for girls, the reduction is somewhere between 0.50 and 2.10. So the mean reduction for girls and the mean is somewhere in this range. We're 95% sure, and we're 95% sure that the mean reduction for boys is in this range. Now look at how much those intervals overlap. It is extremely plausible that the average reduction might be the same in both boys and girls because those confidence intervals have a lot of overlap. So since the confidence intervals overlap, it's certainly plausible that the mean reduction in height is the same for both boys and girls. So hopefully this review of the homework helps you straighten out any problems that you had with it. If you find that you still have any questions, please make sure to ask. I'd be happy to talk with you about it either before or after class or during office hours. Thanks.